So let's pick up from there. Maybe auto text right downstairs. Okay, the car's starting up. So it works the same way with polyatomic ions. Those ones half of you memorized, like nitrate and sulfate and acetate and things. Same thing. Whatever the charge is on the cations, you got to balance it out with an equal number of charge of the anions. So same thing. So let's look at like magnesium and sulfate. So magnesium. Okay, so if you haven't yet, go ahead and pull out your periodic table. Definitely be using that a lot again today. So pull that out, get it handy. Get your periodic table. I'll give you a second to get that out. And hopefully we all have the same one. Please print out the one I put on Blackboard, because here shortly we need to use the numbers off there, and the ones in the lab manual and the ones you find online have different numbers. So find magnesium. What number is it? Number 12. It's in group 2, which means it's 2 plus. Sulfate, you just memorized, is 2 negative. Oh, so that balances out. A 2 plus balances out a 2 negative. No problem, right? So that's easy. How about potassium and chlorate? So find potassium on your table. Potassium is what number? 19. So it's in group 1. So it's 1 plus. Chlorate, you just memorized, well, hopefully, is 1 negative. So a 1 positive bounces out 1 negative. Okay, no problem, right? Easy enough. Well, again, same thing. If they're not equal, if you have more, so here's the only little difference between these and the monoatomic ones I showed you last time. If you want to show you have, let's say, 2 sulfates or 2 phosphates, you got to put that polyatomic in parentheses. So I'll give you an example. If I want to do aluminum, which is find aluminum, group 3, it's in your magic triangle. Remember, so those 3 are 3 plus. And carbonate, 2 negative. Okay, well, so 3 and 2 both combine to make 6. So to have a 6 here, I need 2 aluminums. To have a 6 here, I need 3 carbonates. But I can't just write 3 carbonates like this. I can't do, okay, Al2. Oh, 3 carbonates? Okay, I'll put a 3 here. Now it's 33 oxygens, right? Right? So I have to put, the whole polyatomic in parentheses. So it's 3 carbonates. 9 oxygens, 3 carbons. Yeah, it's 3 carbonates. So that's the only little difference. If you have more than 1 polyatomic, put it in parentheses. If you have more than 1 polyatomic, put it in parentheses. If you only have 1 polyatomic, don't put it in parentheses. So sometimes now students get crazy. They're like, oh, polyatomic, K, parentheses, ClO3. No. Only if there's more than 1 do you need to put it in parentheses. Okay. So, please work with me. Slide. Maybe today. Do you understand?
Yeah, I'm sorry. I don't understand how, why Al2 on the bottom?
So I need a 3 plus and a 2 negative to cancel out. So it shows you one way to think of it is the crossover rule. Put the 3 here, put the 2 here. But why is that? Well, what's the least common multiple of 3 and 2? 6. How do I make this a 6 plus? 2 of them. How do I make this a 6 plus? 3 of them.
And then so the 3 that's on the oxygen, that's what goes on the outside there with the parentheses? Because then you have CO3.
No, I need 3 of those 2 negatives. So I need 3 of that thing.
Oh, 3 of the whole thing. Okay.
3 carbonates, 3 CO3s. Okay, and what's going on here? Saying reconnecting and loading and everything else here. Well, hello. Okay, so let's just try a few now. So let's start putting it together here. So what would the formula be if it was iron 3, that's Roman numeral 3, right, and fluoride? So think here with me for a minute. What does that Roman numeral 3 tell me?
That's plus 3.
Tells me the charge is 3 plus. Not plus 3, by the way. What's the symbol for iron? Fe. That means it's 3 plus. So real quick little reminder. Why do some metals have Roman numerals and some metals don't have Roman numerals? When do they need a Roman numeral?
More than one cation?
When they gain
What's I going to say? Pardon me? Which ones need a Roman numeral? There are some that don't need a Roman numeral ever. And some do, we said. And I hammered it like 6 times. I said, okay, I'm saying it again. I'm saying it again. More than one cation. What do you mean more than one? No?
those that are part of the d orbitals.
So, okay, so I'll go back and remind you. The ones in group 1 never change. They're always 1 plus. The ones in group 2 never change. They're always 2 plus. The ones in the magic triangle are either 3 plus, 2 plus, or 1 plus, we said.
Oh, that's good.
Every other metal can change. So every other metal, you got to specify what the charge is using a Roman numeral. So like sodium, you don't say sodium Roman numeral 1. Sodium's always 1. Or you don't say calcium Roman numeral 2. Calcium's always 2 plus. But all of the other ones can change, so those need a Roman numeral. So I'll say it again for the 18th time. Group 1, Group 2, magic triangle, don't need Roman numerals. Every other metal needs a Roman numeral. Group 1, Group 2, and the magic triangle. So iron is right in the middle, right? Fine, right? It's not group 1, 2, or the triangles. That's why it has a Roman numeral. Yeah, so that Roman numeral 3 tells me it's 3 plus. How about fluoride? What would the charge be on fluoride? Well, fluoride came from what element? Fluorine. So find fluorine. Where's fluorine at? Which number is fluorine?
Group 17.
Fluorine's number 9. So how far away is it from the noble gases?
1.
Just 1 away, so it must have a charge of 1 negative. Or just negative, right. Now remember, as far as the naming goes, "ide." Remember, if it's just a single element by itself going to an ion, then you change the ending to "ide." So fluorine becomes fluoride. Chlorine becomes chloride. Oxygen becomes oxide. Sulfur becomes sulfide. So all of the nonmetals, when they're by themselves and they become an anion, a negative, they become "ide." Right? Okay, so I got a 3 plus and a 1 negative. How can I make those balance out to give me a nice neutral compound? What could I do? What do I need?
I'm sorry, why is it kind of negative at 1 minute?
Okay, so find fluorine. It's right here.
Yeah.
So it's 1 away from the noble gases. So fluorine needs to gain 1 electron to have as many as the stable noble gases. So it gains 1 electron, becomes 1 negative.
Okay.
So how can I make those cancel out? Yeah, I need 1 iron, but I need 3 fluorides, right? Because I got 3 positive, I need 3 negatives. Right? Does that make sense? All right? Any questions on that? I'm sure you have some questions. A few of you, right? Okay, so good, we did that.
Why did you put the number on the bottom instead of...
Because the top means it's a charge.
Oh, okay.
The bottom is how many you have.
Okay, yeah.
Okay, so let's try a bunch. So get out your hand out there. And we're going to go through several of these together. So, let's do cadmium and sulfate. So find cadmium on your periodic table. What number is cadmium?
48.
Okay, so everybody find your table. Everybody find number 48. So based on where it's located, what's the charge have to be on cadmium?
2.
Are you sure? How do you know that?
Triangle.
Okay, so let me look here with you to remind you. This is what I call the magic triangle right here, right? So I told you, these 3 are all 3 plus. Poopy. These 3 are all 3 plus, 3 plus, 3 plus. These 2 are both 2 plus, 2 plus, and this 1 is 1 plus. So yes, those never change. These are always 1 plus, right? Group 1 is always 1 plus. Group 2 is always 2 plus. And the triangle is either 3, 2, or 1. Okay, put that in your brain. Put that in your brain. Don't let it leak out. Okay, so let's go back. So yes, so cadmium. You found it. It's in the magic triangle. It's in the section of 2 of them, so it's 2 plus. So cadmium is 2 plus. Then sulfate you memorized, hopefully. What's the charge? Or not the charge, but the whole thing. What's the formula for sulfate? SO4, yeah, 2 negative. So how do I make a 2 positive and a 2 negative balance out?
Don't they cancel out?
Yeah, just put them right together, right? All it needs is one of each, right? So it'd just be cadmium sulfate.
With 4, right?
Yes, that's sulfate. If it's not 4, it's not sulfate.
Sorry.
No, that's fine. Yes, you always keep these. Yeah, you always keep these. Okay, so lithium carbonate. So find lithium on your table. Which number is lithium? Everybody find lithium? Number 3. So where is it at? Which group's it in? It's in group 1, so it must be 1 plus, because it has to lose 1 electron to become like the noble gases. I would just write Li plus. Carbonates, one of the 10 you had to memorize. So what's carbonate's formula? CO what? 3, 2 negative. Again, don't write -2. I'll start going around slapping people. So -2 is an oxidation number. 2 negative is a charge. So I got a 1 plus and a 2 negative. Those do not cancel out. So what can I do? What kind of ratio between lithium and carbonate can I create to make it balance out? I need 2 lithium, right, 2 to 1, 2 lithiums. So I would write what?
2, Li2, CO3.
Does that make sense? Pardon me?
Why wouldn't the 2 go in front of the lithium? Oh, because we're...
Write it like this?
Yeah.
Okay, so hold on here. So these subscripts tell me how many I have. So I got 1 cadmium, 1 sulfur, 4 oxygen. If I want 2 lithiums, I put it subscripts, 2 lithiums, 1 carbon. So your question was what? Why do I not need what parentheses?
Yeah.
Because there's no possible confusion with
Oh,
this.
yeah.
I mean, yeah, there's no possible confusion. If it was 2 carbonates, I could have put a 2 there because it looked like CO32.
Right.
So polyatomics need parentheses if there's more than one. Read, yeah.
When you're writing the formula for the left side with the Li plus the CO3 2 minus, do you need to put the 2 in front of the Li for the left side before writing them together, since you're balancing them out? So it would be like 2 Li plus.
I mean, the way you
plus
know, you kind of use the crossover and you say, oh, put the 2 here, put the 1 there.
Yeah,
I mean, I don't.
but just for writing it out. So it would be-
I guess I'd never do it that way. I don't know. I've never done it that way.
Oh, it's
I just always just go right to there. I just know, oh, 2 negative ones. I need 2 of these. So Li2. I need 1 of these. So just CO3.
Okay.
So yeah, there's really.
So no need to balance it out when you're adding them out already.
I mean, you could, I guess. I mean, if you're gonna do that, yeah, then I guess I'd put the 2 in the front. I guess if I was gonna do that, but you normally don't need to do that.
Okay.
So let's try potassium hydroxide. So find potassium. 19. It's in group what?
1.
Group 1. So it is 1 plus, not plus 1. Backhand yourself. You keep saying plus 1. It's 1 plus. Okay. Hydroxide is one of the ones you had to learn. So what's hydroxide? OH negative. Okay, so how can I put K positive and OH negative together to make a lovely neutral compound? What can I do? Just 1 of each, K and an OH, right together. Make sense? Okay. Let's look at cobalt-3 cyanide. So, what would cobalt-3 be?
Three plus.
What's cobalt? CO. And the 3 means it's
3 plus.
3 plus. Yes, not plus 3. 3 plus. What's cyanide? CN negative. Okay. So I got a 3 positive, and I only got 1 negative. So how can I make those balance out? Yes. Why can I not write it like that? Because it looks like 1 carbon, 3 nitrogens. But I need 3 cyanides. So polyatomics, got to put the parentheses around there. Don't forget the parentheses. That is the #1 mistake on this. Don't forget to do the they forget to do the parentheses on the polyatomics. Does that make sense, right? Because if not, it would look like 3 nitrogens, 1 carbon. Right? Yeah, that's not right. It's not 1 carbon, it's 3 cyanides. So you got to put parentheses around the cyanide to show it's 3 of everything inside there. Okay, we're learning. Ammonium. What's ammonium? Okay, plus. 1 plus. Or plus. Iodide. Okay, let's talk about iodide. So what iodide come from? Iodine, right. So what's the charge on iodide? 1 negative. Negative. Why? How do you know that? It's 1 away from the noble gases, so it only needs to gain 1 electron to be like the noble gases and be nice and stable. So it gains 1 electron. So how do I put positive ammonium together with negative iodine? What do I do? Yeah, NH4I. Just 1 of each. Boom. Yes, sir.
Why isn't it written as I2? Isn't it? Didn't you say like, oh, they have to be paired up?
If it's by itself, just free by itself, it has to be 2. But again, in a compound, it can be whatever ratio it wants. Yeah. Oh,
Can you specify why iodine didn't need the Roman
iodide.
Yeah.
The anions, the negative ones, never do. It's always just the metals, the positive metals.
And the triangle are the ones that do not make the Roman numerals.
Every other metal. Yeah, iodide's a non-metal, so it doesn't need one. Okay, your turn. Try these. Try them out. See what you can do. So, talk it over. Find magnesium. Figure out a charge. Figure out chlorate. And then figure out how to balance them, put them together.
So regards to the iodide one, but when you are combining the two things, isn't the iodide technically by itself before it's combined with the other thing? Combined with the ammonium? Before
I
it
mean,
becomes a
at
compound?
some point in time in history, it might have been just pure iodine.
Okay.
But when you were making the reaction by that time, it had already been oxidized by something else and turned into iodide.
Okay.
I mean, I'm not sure how to explain it.
So just always when it's just by itself, just by an element, it's always going to be I2.
Yes, if you just find this iodine lying on the ground, it's going to be I2. But iodide in a compound could be anything: I2, I3, I5, I47, or whatever it could be on those. Same thing for the other polyatomics. But in a compound is when you got to worry about it. So yeah, so it was iodide before too. Iodine, yes, iodine is always I2. Iodide means it's
I minus.
it's yeah, right.
Well, thank you.
Okay, so yeah, talk it over with somebody. What'd you get for the first one? Or help each other out. Find magnesium, figure out chlorate. You should know chlorate. So what'd you get for F? Talk it over. Ask somebody. Compare and contrast here. See what you guys got.
So remember these notes? Sulfate. So sulfate and then becomes the ite, so it loses an oxygen.
And then the hypo. Okay. There's just 2 oxygens, right? It's gonna be SO3.
Talk it over.
No, it's SO3 2 minus. Yeah.
Yeah. Okay.
No, talk that one over. That's wrong.
I know.
So when you're going from, just to make sure I have the notes right. So when it's going from 8 to I or whatever, it still retains the charge, right? It doesn't change charges.
Yeah, right.
It just loses an oxygen.
Yeah, exactly. That's all it does. You just lose an oxygen.
Which one? G. Ag2 SO3 3.
So it'd be CLO.
Because sulfate is SO4, and then to become ite, it's SO3.
Is there more than one of them? You need more than one? You need more than one, you do.
Because it lost an oxygen, so usually it's sulfate. It's 4, yeah. I know, I'm not even stupid.
So it would be G would be SO3.
Notice this sulfite for G. What does the ite mean happen?
Loses an oxygen?
One less oxygen.
No,
So
because
sulfate is SO4, 2 negative.
times 2
Sulfite
is
is SO3, 2 negative.
2 times 3.
Ite means it lost an oxygen.
Yeah. Nitrate means it loses the lost one.
Yeah,
Here I have my
What's the element name for VE?
beryllium.
So
Is the name of it?
Is it beryllium?
Beryllium?
No, it'd be AU2.
Which one's E? Beryllium, yeah, beryllium. Protein.
That's for single elements. That's just for elements. These are already combined into polyatomics. They're already combined into elements. Only just sulfur by itself, oxygen by itself. That doesn't actually rule 5. This is why I said you gotta memorize these. They don't follow a pattern. So the sulfates, SO4 2 negative. So sulfite means, oh, it lost an oxygen. So SO3 2 negative. Otherwise,
This is making so much sense.
So it would be Zia.
So let's try it out together here. So, magnesium, you find magnesium. It's in group 2, so it's 2 plus. Chlorate you memorized, maybe. ClO3 negative. So I need a 2 positive to balance out a 1 negative. So I need 2 of those chlorates, right? So the way I write that is Mg, then I gotta put parentheses, right? ClO3, parenthesis, and then a 2 there. Okay, let's try gold sulfite. So gold is what symbol for gold? Au. And the charge is yes, the Roman numeral 3 tells me it's 3 plus. Sulfite. Oh, ite means lost an oxygen. So sulfate is SO4 2 negative. So this must be SO3 2 negative. So what's the least common multiple of 3 and 2? 6. So to have a 6 on the gold, I need 2 of them. To have a 6 on the sulfite, I need 3 of them. But of course, don't forget, put it in parentheses. Okay. What's zinc's charge? Find zinc. Which number is zinc? Zinc is number... Zinc's number 30. Everybody find number 30? So zinc lives in the magic triangle. Da, da, da. So it's always what? 2 plus. Nitrite again. Ite means lost an oxygen. So, think back. Okay, so what's nitrate? NO3 negative. So nitrite is NO2 negative. Okay, so I got a 2 plus and a 1 negative. Well, how do I make those balance out? Zn, parentheses, NO2. Awesome. So I have 2 of the negative nitrates. Okay, lead Roman numeral 2 phosphate. So lead 2 phosphate. What's lead symbol? PB, peanut butter, and 2 plus. What's phosphate? PO4, 3 negative. Okay, how can I put those together? PB3, right? Parentheses PO4, parentheses, because again, right? So try to make them both cancel out. So 2 and 3 can both go into 6. So to make that a 6, I need 3 of them. To make that a 6, I need 2 of them. Okay. Last one, cesium acetate. What's cesium? CS, and what's the charge on it then? So in group 1, so it's 1 plus. What's acetate? C2H3O2, 1 negative. So how do I put those together to make them neutral? Just right together, yeah. CS, C2H3O2.
You don't need a parentheses even though it's a...
Yes, why do I not need a parentheses?
Because there's not.
Because there's only one of them, right? Yes, right. There's only one of them, so no parentheses. If there was more than one, they have to show that, else it would look like 22 oxygens or something, right? So, okay. Well, now let's try it the other way. So that was the easy way. Let's try it the other way. I'm going to give you the formula, and you're going to tell me the name. So normally it's pretty easy to figure out. So remember, the total of the positive cations has to equal the total of the negative anions, right? So same thing. So let's figure this up. So Cr3N2. Cr3N2. So what's Cr called? Write this again. Let me try this again. I'll write it down here. Cr3N2, right? Okay, yeah, so Cr is called chromium. Will chromium need a Roman numeral? Fine. Yes. Why?
It's outside the magic fish.
It's not in group 1. It's not in group 2. It's not in the magic triangle. So we'll need some kind of Roman numeral. But we don't know what it is yet. So we're going to figure it out based off the charge on the other thing. So how would I name... So nitrogen is not combined with any oxygens or anything, right? Just a non-metal hanging out by itself. Well, has another one, but it's by itself. So how do you name that then? Yeah.
Base it off how many charges of the N are given,
How many...
or like how many. Base it off the N, right?
Yes, it's based off the N. Yeah, so how would I name that?
Chromium 2.
No, just name me the N part. Just the N part.
Nitride.
Nitride. Why is it nitride?
Just by itself.
Non-metal by itself always goes to ide. Fluorine to fluoride. Chlorine to chloride. Sulfur to sulfide. Nitrogen to nitride. Again, it's not combined with any oxygen, so it's not nitrates or anything like that. Okay, so just non-metal by itself. Okay, perfect. So let's figure out then, what's the charge on every nitride? So find it on your table. It must be what charge normally?
3.
It's 3 away, so it must be 3 negative. Right? Everybody agree with that? It's 3 away from the noble gases, so it must be 3 negative. Well, how many nitrides do I have? 2 of them. So I have 2 3 negatives. That's a total of 6 negative. Okay, so if all of the anions equal 6 negative, then all of the cations must equal what? Yes, so if these are 6 negative, these must be 6 positive. Right? Does that make sense so far? But I have 3 chromiums combining to be 6 plus. So what times 3 would give me 6 plus? 2 plus. Each chromium must be 2 plus. Try that again, all right? So nitrogen you can find, it's by itself. So just look at right in your table. So it's 3 away, so it's 3 negative. I have 2 of those 3 negatives, so that's a total of 6 negative. Oh, well, if these are all 6 negatives, then these must all be 6 positive. But I've got 3 of them combining to be 6 positive. So 3 times what is 6? 2 positive. So I would name it what? Chromium what? 2. Because it was 2 positive, right? Right? I put a 2 here because it was 2 positive, we figured out, right? So chromium 2. Okay, I'm going to warn you. I told you last time, the crossover rule works going from name to formula. It will bite you in the ASS going from formula to name. It happened to work this one time where, yes, the 2 became the same as the 2 here. It does not work more than half the time. So do not trust that. Do not just unswitch them. So I warned you last time, like I said. I was kind of, I was kind of hesitant to, hesitant. I was saying last time to kind of show you that rule because students always want to use it in the reverse way, and it will bite you in the butt more times than not. So just always figure it out. Okay, good. Let's try. Okay. So when we're naming them, we already know how to name this. I'm just going to real quick. Cation goes first, normally the metal. The anion goes second, right? If it's not in group 1, 2 of the triangle, the cation needs a Roman numeral. Okay, so let's look at this one just real quickly. MgO. So Mg, magnesium. Oxygen all by itself, not in a compound, which means you do what?
Oxide.
Change it to ide, so oxide. So easy, magnesium oxide. Why does magnesium not need a Roman numeral?
It's in the
Because it's in group 2.
It's in group 2, right? Group 1, group 2, magic triangle, doesn't need a Roman numeral. Awesome. Okay, how about this one? Here's a mineral. It's called cinnabar. And it has the formula HGS. So, what's Hg called? Mercury. Will mercury need a Roman numeral or not? Or is it always constant? Yeah, find it, yep. It's what number? Everybody find it? 80. Okay. Is it in group 1, group 2, or the magic triangle? Nope. So we're going to need some kind of Roman numeral. How do I name that sulfur? All by itself, not combined with anything, so it becomes ide, sulfide. Okay, so let's figure it out. What's the charge on that sulfide? It's 2 away from the noble gases, so it's 2 negative. Perfect. Okay, how many sulfides do I have?
1.
Just 1, so all of the negatives are 2 negative, which means all of the positives must be 2 positives. So that 1 mercury must be 2 positives. So you would name it mercury 2. So you figure out the charge on this based off the charge on the anion. So the anion always tells you what the cation is going to be. You have to balance out. Okay, let's try. Whoop, whoop, too crazy. Okay. K2CO3. How would I name K2CO3? So what's the K called?
Potassium.
Potassium. What's CO3? Oh, wait, no, I'm sorry, back up. Potassium. Okay, first things first. Will potassium need a Roman numeral?
No.
Why not? Convince me.
Group 1.
It's in group 1, right? It's always 1 plus. It doesn't change, so you don't need to specify the charge. Awesome. What's CO3 called? Carbonate. Boom. You just named it. Not bad, right? Potassium and a carbonate. No problem. Okay. Let's try this one. What's CO? Cobalt. Does cobalt need a Roman numeral?
Yes.
Yes. Where is it? What number is it?
27.
It's 27. Okay, why does it need a Roman numeral?
Because
Because it's not in group 1, group 2, or the triangle.
It's not in group 1, group 2, or the what?
Magic
The magic triangle. Thank you, it's a magic triangle. It's a magic triangle. So yes, it will need a Roman numeral. How do we figure it out? Well, we figure it out by figuring out what this ClO3 crazy thing is. So what's ClO3 called? Chlorate. Good. Awesome. So what's the charge on chlorate normally? 1 negative. How many chlorates do I have? 3. So I have a total of 3 negatives. See how I'm doing that? So if all of the negatives are 3 negatives, all of the cations must be what? These must all be 3 positive, right? And how many cobalts do I have? Just 1, so that 1 cobalt must be 3 positive. Does that kind of make sense? So what would I write there? Roman numeral 3. I. Okay, I do have a bunch of videos on this on my YouTube Get Chemistry Help. I really encourage you to watch them. They tend to be pretty helpful. And the one thing you need in chemistry over and over is just buttloads of practice. Just practice it until it's second nature. So let's try these 5 together. See what we can do here. So how do I name this NH4Cl? So NH4 is called what? Ammonium. Does that need a Roman numeral or anything? No, of course not. Right. Yeah, exactly. Yeah. Ammonium is just ammonium is just one of the polyatomics you have to learn. Chlorine all by itself. Chloride. Change the ending to "ide." Boom. Couldn't be easier. Ca and that whole thing. So what's the Ca? Calcium. Does calcium need a Roman numeral? Why not? It's in group 2. Everybody see that? Okay, no Roman numeral. What's that other hairy thing called? Acetate. Calcium acetate. Okay, so far so good. What's Cu? Copper. Does copper need a Roman numeral? Yeah. Aha, why does it need a Roman numeral and the other ones didn't? It's not in 1, 2, or not 2. Yes, exactly. I will keep saying this 50 times if I have to until it sticks in your brain. Okay, so what's that NO3 thing called? What? Nitrate. Okay, so needs a Roman numeral, so we got to figure it out. So what's the charge on nitrate? 1 negative. But how many nitrates do I have? 2. So it must be a total of 2 negative. Awesome. So if those are all 2 negative, then the coppers must add up to be what? 2 positive. How many coppers do I have? How many coppers do I have?
1.
It's got 1 copper, so that 1 copper must be a 2 positive. So I put copper Roman numeral 2. Okay. Be and then that messy thing. So what's Be? Beryllium. I'm sure you can all spell that. Does beryllium need a Roman numeral? Why not? It's in group 2. ClO2. ClO2 is not one of the ones I memorized, but I did memorize something similar. You learned chlorate, ClO3, right? So this has 1 less oxygen, so yes, it's called chlorite. Ite? Ite? Okay, good. Okay, let's try the last one. Yes?
Why does it get the ite again?
Because it had 1 less oxygen than the 8. Chlorate's the one you learned, ClO3. I say, aha, 1 less oxygen, so I turn it to ite. Ite? Okay. What's Sn? 10. Does that need a Roman numeral?
Yes.
I heard no and yes.
Yes.
Convince me.
It's not in group 1, 2, or the triangle.
Or the what? Magic triangle, thank you. Yes, not group 1, 2, or the magic triangle. So yes, it will need some kind of Roman numeral in here. What's that CN thing called? Cyanide, everyone's favorite. What's the charge on cyanide? 1 negative. How many cyanides do I got? I got 4, so that makes it a total of 4 negative. So if all the anions are 4 negative, all of the cations must be 4 positive. How many of those do I have? Just 1, so that 1 must be 4 positive. So I would write 10, what? 10-4, good buddy. 10-4. Okay, your turn. Try the next, whatever we got there, 5 or something. You sound thrilled. I heard groaning. Help each other out. Find a buddy. Work together. It's the easiest way. Okay, so I'll go over them with you. Okay, so let's do. I'll do them fairly quickly because I hope we're kind of getting it, but I'll do some. Zn is zinc. Does zinc need a Roman numeral? No, it's in the magic triangle. What's CO3? Carbonate. Zinc carbonate. Perfect. SR.
Strontium.
Does strontium need a Roman numeral?
No.
Why not?
Group 2.
It's in group 2. It's always the same. How about N? How would I name that?
Nitride.
It's just nitrogen by itself, right? Right, yes, exactly. Just nitride. It's not combined with any oxygens or anything. So just ide. Nitride. Mn. What's Mn? Manganese. Manganese. Does manganese need Roman numeral? Yes, because it's not in group 1, 2 of the triangle. What's the S by itself called?
Sulfide.
By itself, so ide, yes. Okay, so here we got to figure it out. So we do the little thing I just showed you. So what's the charge on sulfide? So you find sulfur. It's 2 away from the noble gases. Everybody see that? You count over 1, 2 to get to the noble gases. So it's 2 negative. How many of those 2 negatives do I have?
7.
So 7 times 2 is 14 negative. So if those are all 14 negative, then the manganese must all be 14 positive. But it's not manganese 14. Why not? Oh, there's 2 manganese. So 2 times what gives me 14? 7 plus. So manganese 7. VII. Okay, now again, here it happened to work. The crossover rule happened to work. 7 and 2 in reverse. But again, it does not always work, so don't do it. Always do it the way I just showed you. Just work it out to be safe. Okay? Work it out to be safe. Okay. I'm going to clear it off here. Just make a little room here. How about the next one? What's Ag? Silver. Does silver need a Roman numeral? Why not? Okay, good. Oxygen by itself? Oxide. Easy. Fe. Does iron need a Roman numeral? Aha, yes. Because it's not in group 1, 2 of the magic triangle. What's OH negative? Or OH called hydroxide. That's just one you had to learn. Okay, so now let's figure it out. What's the charge on hydroxide? 1 negative. How many of them do I have? 3, so that's a total of 3 negative. So if these are all 3 negatives, these must all be 3 positives. How many irons do I have? Just 1, so that 1 iron must be 3 positives. So iron 3. Okay. I think we're slowly getting it. That's good. But I will just warn you again, though. The best way for you to reinforce this while you're still kind of getting it now, go home and do some homework. Practice it. The worst thing you can do is be like, all right, I got it, and then not think about it until next Monday in class, and you'll be like, what the freak are we doing in class? I know it made sense then. I'm telling you. Go home tonight and just practice to write a few tonight. Practice a few tomorrow. Watch a video on Saturday, right? Practice whatever, right? Just do some homework. practice. The best way, just reinforce it, reinforce it, reinforce it. That's the way you make it stick. Don't just be like, I'm free of chemistry till Monday, or you will be really free of chemistry when you are failing the class and not, right, you're failing the class and no longer enrolled. Okay, so what I just showed you was how to name ionic compounds. So, now just forget all that. Now I'm going to show you, already done, right? Done, already forgot. So now I'm going to show you how to name molecular compounds. Again, 2 classes of compounds. So I know I said last time, the most important thing to know early on is, what kind of compound is this? Is it ionic, and then I name it the way I just showed you? Or is it molecular? I'm going to name it the way I'm going to show you now. So, ionic compounds are made up of ions. So you look for either a metal or a polyatomic. If you see a metal or a polyatomic, we immediately knew it was an ionic compound. How do you know something is a molecular compound? What do you look for? Nonmetals. If all of the elements are just nonmetals, so again, nonmetals are up in the top right quadrant of your table. So if all the elements come from that top right quadrant, then it must be a molecular compound. Remember that now? So if all the elements in there are nonmetals and there's no polyatomics, there's no metals, then it has to be a molecular compound. So if it's like CO2, carbon and oxygen are both nonmetals, right? Or I don't know, or COF3, chlorine and fluorine are both nonmetals. Those are going to be molecular compounds. Okay, these are super easy to name. I can teach you this in 2 minutes. It's really easy. All you do, the first element, just name it the name. So let's say it's CO2. See, carbon, boom. O2, okay, next one, change it to ide. Oxygen becomes oxide. That's the first thing you do. And then I'm going to put in a little Greek prefix to tell you how many carbons, how many oxygens do I have. So here are the Greek prefixes from 1 through 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So most of these you probably already kind of know. You probably already know. You know, hexa, you probably know is 6, and penta is 5. Now, you know, octa, right, an octagon or an octopus. You might not know 7, 9, and 10. Those are kind of weird. And one semester back at Fresno a few years ago, I happened to have in one class, I had 3 students from Greece in the same class. And they weren't even all related. They just all been in the same class. So I got to this, and they all began to laugh at me when I got to number 9, because apparently nona is not actually Greek for 9. Nona actually, nona actually was Greek for godmother. So it was like, 7, 8, godmother 10. They were like, wow. They were all laughing at me. So the only little thing to keep in mind is we don't use mono if the first nonmetal is just 1. So for example, we don't say monocarbon dioxide. We just say carbon dioxide. But we do say carbon monoxide for the second one, right? That's pretty much it. That's all you got to do. Name the first element, name the second one, change it to ide, and then put one of these prefixes in front of it, which will tell you how many you got. So no figuring out charges or anything, because they're not charged, they're not ionic. So these members share electrons. These do not transfer electrons. Okay, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Got them? Fight faster! Okay. Nona, deca. Okay. The only one remember though is we don't normally say monoxide. You probably know we don't put those 2 O's together. We say monoxide, right? But I heard that. I'm sure you've heard that, right? Carbon monoxide. You don't say carbon monoxide. So we do just lose one of the O's just to make it a little easier to pronounce. Otherwise, we keep all the vowels. So yeah. You know, we do say monoiodide. Yeah, that's fine, or whatever. Just with oxygen. Okay, so let's try one real quick. So P4S3. Okay, find phosphorus. Which number is it? Find sulfur. Which number is it? Okay, they are both up there in non-metal land. Do you see that? Convince yourself. They're both non-metals. So this is a molecular compound, so I can use the easy way of naming them. So P, I would just name, right, just whatever it is, phosphorus. S, I would just name, change it to ide. So I would put what? Sulfide. I have 4 phosphorus though. So what do I put for 4? Tetra. What do I put for 3? Tetraphosphorus trisulfide. Isn't that much easier? Just 4 phosphorus, 3 sulfurs. Tetraphosphorus trisulfide. Okay. How about N2O4? So first off, just kind of convince yourself that is a molecular compound. Find nitrogen and oxygen. Are they both nonmetals? Do you find nitrogen and oxygen really? Which numbers are they?
7, 8.
7 and 8, right? They're both up there on the top right quadrant, right? So, how do I say 2 nitrogens? Di-nitrogen. Di-nitrogen. Di. And how do I say 4 oxygens? Tetra, and then oxide. Yeah, make that one ide. Yay! Awesome. Okay. I'm so confident you can do this. I'm gonna let you try it. Just jump in and do these 5. So let's go over these. NO2. Okay, 1 nitrogen, but again, don't say mono for the first one. So just say nitrogen. You only use the mono if the second one's 1. And then 2 oxygens, how would I say that? Dioxide, right. 1 phosphorus and 5 chlorines. How would you name that? Phosphorus pentachloride. Awesome. I'm going to put this up there. I actually have these typed out here. Just remember. 2 iodines. How would I say that? Diiodine. Now, again, yes, you do keep both I's in there. I know it sounds weird, but you do keep them both in there. The only one you drop is that one I showed you, monoxide. Keep them all together. So diiodine, heptafluoride, right? Not fluoride. Did you put OU? There's no flour in fluorine. It's fluoride. UO, not OU. Okay? 3, what's that SB called? Antimony. So how would you say 3 antimonies? Tri-antimony. And then 9 chlorines. Godmother chloride. Nona chloride. Yes. Now technically, if you find antimony, it is number 51. It is a metalloid. So remember I told you metalloids are these weird hybrids. They're kind of like metals, kind of like nonmetals. You could actually name that one either way. So here I named it like it was a molecular compound. But I could have named it like it was an ionic compound and said antimony 3 chloride. That would have worked too. So I could have done it either way actually. So warning to self, right? Are you with me? It's a metalloid, so it's kind of your choice. You can name it molecular, which is the easier, or you can do the hard way and figure out, oh, okay, so there's chlorides 1 negative, there's 9 of them, that's 9 negative, so the antimonies are 9 positive, there's 3 of them, so each one's 3 positive. Antimony 3 chloride. You could do it that way too, I'm just telling you. Okay, how about the last one? 4 phosphorus would be tetraphosphorus. 8 oxygens, octaoxide. Isn't that fun to say? Octaoxide. Okay. And then the other way is super easy, I think, so let's do them real quick. Dinitrogen tetraoxide. What would that be? N2O4, right. Sulfur hexafluoride would be SF6, right? Diarsenic would be, what's the arsenic symbol? AS. So AS2 trisulfide. S3, right? Diselenium monoxide. SC2O. 2 seleniums and 1 oxygen. And pentanitrogen godmother chloride. N5CO9. N5CO9. Wasn't that fun? Okay. Let's put it together. And I have now mixed them up. I've shuffled them. Some of these are ionic. Some of these are molecular. So the first rule of thumb I told you, figure up. If you see a metal or a polyatomic, you know it's ionic. If all you see is a bunch of nonmetals and no polyatomics, then you know it's a molecular. So the first thing I'm going to figure up is Al2S3. Is that ionic or is that molecular? How do you know that is ionic? Prove it to me. Aluminum. I'm going to put an I here. That is, actually, I'll put it over in the side. I, because it's ionic, just to remind myself. Aha, so that means I'm going to use the ionic rules, where I name the cation, and then I name the anion. Don't use any prefixes or any of that stuff. So what's Al called? Aluminum. Will that need a Roman numeral? Why not? It's in the what? Magic triangle. And what's sulfur by itself called? Sulfide. That was easy. Aluminum sulfide. Okay, perfect. How about the next one? P2O5. Ionic or molecular? Why? You're right, but why? Phosphorus and oxygen are both nonmetals up in that top right quadrant. So how do I name that? Diphosphorus pentaoxide. Yes, you're awesome. Perfect. Great. All right. So it's the molecular ones you get to do it the mono-di-tri way. Okay. Copper. Okay. And 2OH, is that ionic or molecular?
Ionic.
How do you know?
Copper.
It's got a metal and it's got a polyatomic. So you got 2 clues there. I'm going to sit down. Okay, so Cu is copper, right? Does copper need a Roman numeral?
Yes.
Aha, it does. So copper is something. What's that OH called? Hydroxide. So let's figure it up. What's the charge on hydroxide? 1 negative. How many of these 1 negatives do I have? 2. That's a total of 2 negatives. So all the coppers must be 2 positive. How many coppers do I have? Just 1, so the 1 copper must be 2 positive. So copper 2 hydroxide. Right?
Yes, sir.
Okay, how about the next one? Ionic or molecular? How do you know? Potassium's a metal. Yes, exactly. They're not both nonmetals. So, K is potassium. Does that need a Roman numeral?
No.
Why not? It's in group 1. Okay, so potassium, what do I call oxygen by itself? Oxide. Potassium oxide. Okay, CS2, ionic or molecular? Why?
Because carbon and sulfur.
Carbon and sulfur are both up in the top right? Up in the non-metal land. So, how would I name that then? Carbon disulfide. Right now I use the prefixes because it's molecular. Make a little note there, right? Molecular, put a little M, just remind yourself. Okay, how about the next one? Ionic or molecular?
Ionic.
It is ionic because I see polyatomics. Now this one sometimes is confusing because they are all nonmetals. But remember, those are polyatomics. NH4 is a polyatomic ion. CO3 is a polyatomic ion. So it's got ions. It's definitely ionic. So how would you name NH4? Ammonium, and then CO3, carbonate. So just ammonium carbonate. Okay, last one I'll do with you, and then we are out of time. Fe,
Iron.
iron. Okay, back up first. I'm sorry. First off, is it ionic or is it molecular? Definitely ionic because it's got a metal and a polyatomic. Iron, does iron need Roman numeral? Yes. What's that C2H3O2 called? Acetate. What's the charge on that?
Minus
1 negative. And I have 3 of them, so that's 3 negative. So the irons are all 3 positive. There's 1 iron, so it's 3 positive, so iron 3. Awesome. Okay, so I'm telling you, do yourself a big favor and practice this tonight or tomorrow, and then a little bit the next day, right? Just do a little bit of the homework, watch some of the videos, something. Else, I promise you by Monday, you will have totally forgotten this. And yes, exactly. Agree with me because I know you know I'm right. You don't practice it. So, okay, so I will see you on Monday. Is that our last week before spring break? This is the last week?
Yeah, right?
I think it is. Woohoo!
How do you know when if it's ionic or